Okay, so this example. A machine is designed to make paper clips with mean of mass 4.00 grams and a standard deviation of 0.08 grams. The distribution of the masses of the paper clips is normal. Find. So the probability that an individual paper clip chosen at random has a mass greater than 4.04 grams. Standard error, which we talked about in the preamble to this piece of work. The probability that the mean mass of a random sample of 25 paper clips is greater than 4.04. So that's all working with normal distributions and the related probabilities, and then we come to the hypothesis test in the fourth part. So if we work through the first up, so I've got a normal distribution, so I'll declare my random variable. We're talking about a mass, so let's have a capital M. So M be the random variable, the mass of a random M be the random variable, the mass of a randomly selected paperclip. In which case, the parent population will have normal distribution with a mean of 4 given to 2 decimal places and a standard deviation of 0.08. So that's our parent population. So the first thing the question wants us to do is to find the probability that a randomly selected clip, should be lowercase, sorry, uppercase, is greater than 4.04. So this is a bit of revision from normal distribution. So calculator 7, normal cumulative, lower 4.04, upper 1 times 10 to the 99, standard deviation 0.08, mean 4, what's the probability? 0.309. So you've got a 31% chance of a randomly selected paperclip having a mass of greater than 4.04 grams. The standard error, if you look back at the list of the properties of the central limit theorem, standard error is standard deviation divided by the square root of the sample size. So that's going to be 4 over square root of 25. Did I say 4? I meant 0.08. So start again. Standard deviation is 0.08, not 4, and the sample is of 25 paper clips. So you're going to be doing 0.08 divided by 5, 0.016. The probability that the mean mass of a random sample of 25 paper clips is greater than 4.04. So I'm not talking now about the parent population, I'm talking about the sample population. So for the sample population of means, M bar is going to be normally distributed. It's going to have the same mean, and its standard deviation is going to be 0.016. If I just keep writing it as I have been in the previous examples, it'll keep that consistent, so that's the variance, which means the standard deviation is 0.08 over 25, over the square root of 25, which we know is 0.016. So we want to know what the probability is that the mean is going to be greater than 4.04. So coming back to my normal distribution, cumulative, lower 4.04, upper 1 times 10 to the 99, standard deviation is going to be 0.016, and the mean is same as before, 4. So the probability that the mean is going to be greater than 4.04 is 6.21 times 10 to the minus 3, which is 0.0062. So no hypothesis testing there. The only thing that's extending that from the normal distribution work we've been doing previously is that we bring in this sample population of means. So let's go back to the question. A quality control officer weighs a random sample of 25 paper clips and finds their total mass to be 101.2 grams. Conduct a hypothesis test at the 5% significance level of whether this provides evidence of an increase in the mean mass of the paper clip. So it's going to be one-tailed again, and we're still dealing with increases. So the first thing we need to do is to work out our calculated sample mean. They're telling us the total mass is 101.2, and there are 25 of them. So lowercase m bar is going to be 101.2 divided by 25. So 4.048. So I've got my normally distributed sample population of means, and I've got the calculated mean for the sample that has been taken. So the null hypothesis will be no change to the mean mass of the paper clips, so the mean will be 4. No increase in mean mass of paper clips. The alternative, and we're talking about an evidence of an increase, is mu is greater than 4. So the mean mass has increased. We're performing a one-tail test at a significance of 5%. Method 1, p-value. So we've got a mean of 4, and I want to know what that area is, which generates a calculated mean 4.048. So I want to know probability that m is greater than that. So p-value so menu 7, normal cumulative, lower 4.048, upper 1 times 10 to the 99, standard deviation 0.016, and the mean is 4. So I've got 1.35 times 10 to the minus 3, which is 0.00135. I'm only testing this at 5%, so that's clearly within that 5% tolerance. So hence H0 rejected. If I went method 2, then I'm interested in finding out what value of M reduces a region of 5%. On my calculator, because it's less than, my area that I'm going to be typing into my calculator is 0.95. So back to the menu, inverse normal this time, area 0.95, everything else stays the same. So that critical value is 4.03. My calculated mean was 4.048. So it's within the critical region. So the critical region has a mean greater than 4.03, sample mean of 4.048 lies within critical region, therefore H0 rejected. And then the conclusion that we can draw from whichever method we chose is to say, hence there is sufficient evidence to suggest that the mean mass has increased. So hopefully now, 3 examples in, you're getting a feel for the quite repetitive nature of dealing with these hypothesis tests.